Many people imagine a black hole as a ravenous monster with such immense gravity that even light cannot escape it. It is believed that once an object crosses the event horizon, the point of no return, there is no way back. However, this idea gives us reason to think twice. Quantum physics, which describes how our world works, states that information cannot be destroyed. If this principle also applies to black holes, a paradox arises. This is why Stephen Hawking proposed a new hypothesis. Perhaps black holes do not have an event horizon at all. Instead, there may be what is called an apparent horizon, which holds matter and energy only temporarily before releasing them back into the universe in an altered form. This would mean that black holes do not destroy information, but merely transform it. If this theory is correct and event horizons do not exist, then black holes as we traditionally understand them may not exist either. This leads to a much larger question about the fate of the universe. Will it end in a big crunch, a big rip, a big freeze, or perhaps a big slurp? Many astronomers believe that the universe could cease to exist sometime between 2.8 and 22 billion years from now. Since it is still expanding, it is reasonable to assume that it once emerged from an extremely dense state. And if the universe had a beginning, it likely has an end as well. However, scientists have yet to reach a consensus on how that end will occur. One of the most popular theories is the Big Crunch. According to this idea, the expansion of the universe will eventually slow down, and gravity will become the dominant force. This would cause the universe to collapse, forcing planets, stars, and galaxies to collide with one another. Essentially, it would be the Big Bang in reverse. The Moon is the closest planetary satellite to the Sun, since Mercury and Venus, both closer to the Sun than Earth, have no moons of their own. Perhaps they simply have enough cable television. The Moon has a diameter of 3,475 kilometers, making it the fifth largest moon in the solar system, after Jupiter's moons Ganymede, Callisto, and Io, and Saturn's moon Titan. From Earth, the Moon appears roughly the same size as the Sun, even though the Sun is about 400 times larger. The reason is that the Sun is also about 400 times farther away, which makes both objects appear nearly equal in size in the sky. Although the Moon looks bright, its reflectivity is 3 times lower than that of Earth. This is why it is often artificially illuminated in group photographs. To match the intensity of daylight at noon, it would take about 300,000 full moons. 206,000 of them would need to be full at the same time. Each year, the Moon moves about 3.8 centimeters farther away from Earth. Initially, it was only about 22,000 kilometers away, but today the distance is nearly 400,000 kilometers. In roughly 600 million years, its apparent size will become so small that total solar eclipses will no longer occur. If you're still around then, feel free to leave a comment. The Moon is also responsible for Earth's tides. Its gravitational pull affects the oceans, and the highest tides occur during full and new moons. Because the Moon lacks a dense atmosphere, its surface experiences extreme temperature swings. Near the lunar equator, temperatures range from about 173 degrees Celsius at night to plus 127 degrees Celsius during the day. The problem of pollution is not limited to Earth's oceans, cities, and forests. There is also such a thing as space debris, any human-made object left in space with no further purpose. In addition, there is natural debris formed by meteorites and other celestial bodies. Currently, more than 500,000 pieces of space debris orbit Earth at speeds high enough to damage satellites or spacecraft. NASA and other space agencies work tirelessly to track these objects and ensure the safety of missions beyond Earth. Have you ever looked up at the night sky and tried to count the stars? Good luck with that. Our galaxy alone, the Milky Way, contains around 100 billion stars, and some estimates suggest there may be over 200 billion. Accurately counting them is nearly impossible even within a single galaxy, let alone the entire universe, which is estimated to contain at least 1 billion trillion stars, a number with 21 zeros. For comparison, there are more stars in the universe than grains of sand on all of Earth's beaches combined. When the planets of the solar system were still forming, Earth did not have a moon for a long time. The formation of the moon took hundreds of millions of years. There are several theories about its origin, but the most widely accepted is the giant impact hypothesis. According to this theory, a large celestial body collided with the early Earth, ejecting massive amounts of debris into space. Over time, gravity pulled this material together, forming the Moon and placing it into its own orbit along the plane of the ecliptic. If we ignore the Sun, traveling to the nearest star by airplane would take about 5 million years. Crossing the Milky Way from one end to the other would require roughly 100,000 years. Even at the speed of light by airplane, the number would be so large it's hard to even imagine. The Sun is so enormous that it could fit about 1 million Earth-sized planets inside it. Yet even it is not the largest star known. There is a star called Scuti that is approximately 1,700 times larger than the Sun. Almost everything in the universe is connected by gravity. Stars form systems. Systems make up galaxies. Galaxies gather into clusters, and clusters form superclusters. The largest known structure in the universe is the Hercules Corona Borealis Great Wall, which spans more than 10 billion light-years. Mars is home to the largest natural features in the solar system. Olympus Mons is nearly 3 times taller than Mount Everest. A massive canyon stretches almost 7 times longer than the Grand Canyon, and the largest craters rival half the length of the Amazon River. Although the Big Bang Theory is considered the most likely explanation for the origin of the universe, some scientists continue to explore alternatives. One such hypothesis suggests that the universe has a preferred axis of rotation, ominously referred to as the axis of evil. At the center of most large galaxies, including the Milky Way, lies a supermassive black hole. These objects can attract not only stars and planets, but also other black holes. When they merge, they grow even more massive, and, due to their rotation and immense gravity, can sometimes eject streams of matter moving at nearly the speed of light. Beyond our galaxy lies a mysterious gravitational anomaly known as the Great Attractor. It cannot be observed directly, but scientists know that it is pulling the Milky Way and many other galaxies toward it. Olympus Mons. The tallest mountain in the solar system is also located on Mars. Measured from sea level, it is 3 times higher than Everest. However, if you stood on its summit, you might not even realize you are on a mountain, as its slopes blend almost seamlessly into the surrounding terrain. The Moon's gravity is only about 17% of Earth's. If you weigh 70 kilograms on Earth, you would weigh only about 12 kilograms on the Moon. This would allow you to jump 6 times farther and lift objects 6 times heavier than on Earth. However, despite the ease of movement, the Moon is still dangerous. Astronauts' boots can sink up to 15 centimeters into the lunar soil, and long jumps are risky due to the many deep craters. Jupiter's Great Red Spot is a massive atmospheric storm that has existed for centuries. In the past, it was large enough to contain 2 or even 3 Earths, but it has since shrunk and now barely covers the area of a single Earth. In the vacuum of space, 2 pieces of the same metal that touch can permanently bond together in a process known as cold welding. On Earth, this does not happen because air and moisture prevent direct atomic contact. The Moon does not have a perfectly spherical shape. Under the influence of Earth's gravity, it is slightly stretched and resembles an egg, with its pointed end facing our planet. Ordinary visible matter stars, planets, and galaxies makes up only about 5% of the universe. Roughly 27% consists of dark matter, while around 68% is dark energy. As a result, we know almost nothing about 95% of the cosmos. Beyond Neptune's orbit lies the mysterious Kuiper Belt A region filled with large icy objects. Scientists are particularly intrigued by the unusual orbital patterns of these bodies, which may point to the existence of another massive planet, commonly referred to as Planet 9. Its existence, however, has not yet been confirmed. On Venus, you wouldn't just struggle to keep a hat on, you would have difficulty standing at all. The planet's atmosphere is in constant motion, with winds blowing at speeds dozens of times faster than Venus's own rotation. Over time, these winds may become even stronger. To leave the solar system, one would need to travel roughly 17.7 billion kilometers from Earth. Google Maps is unlikely to be of much help on such a journey. Methane is a gas produced by natural processes such as volcanic activity and biological reactions. On Mars, its presence deeply puzzles scientists, as methane levels there continue to rise while its source remains unknown. So the question, "Are there cows on Mars?" remains unanswered for now. Pluto was once considered a full-fledged planet, but in 2006 it was reclassified as a dwarf planet. The decision was controversial, yet one of the most surprising facts about Pluto is that its diameter is smaller than the width of the United States. To put this into perspective, the distance across the US from Maine to Northern California is about 4,500 kilometers, while Pluto's diameter is only around 2,370 kilometers. If Pluto were placed at the center of the United States, Iowa, Kansas, and Nebraska would barely remain. Not exactly a great idea. The next object is Uranus. This planet rotates while essentially lying on its side. Scientists still have no definitive explanation for its extreme axial tilt. One leading hypothesis suggests that Uranus experienced one or more massive collisions in its distant past, but this remains unproven. Notably, Uranus is the only planet in the solar system with such an extreme tilt. The Sun is a star of colossal proportions, and the numbers are striking. 99.86% of the total mass of the solar system belongs to the Sun itself, composed primarily of hydrogen and helium. The remaining 0.14% accounts for the combined mass of all 8 planets. A light year is a unit of distance, not time. It represents the distance light travels in 1 year at a speed of just over 300,000 kilometers per second. 1 light year equals roughly 10 trillion kilometers. For comparison, the Milky Way is about 105,700 light-years wide. And yes, this may sound surprising, but there is an enormous amount of water in space. Astronomers have discovered a massive cloud of water vapor whose mass exceeds that of all Earth's oceans by 140 trillion times. Fortunately, it lies about 12 billion light-years away, so we won't be drowning anytime soon. Saturn's rings were not discovered all at once. They were identified gradually and named using letters of the Latin alphabet in the order of their discovery: D, C, B, A, F, and G. Jupiter is home to the famous Great Red Spot, a gigantic atmospheric vortex larger than Earth itself. Scientists have confirmed that it is a persistent storm that has been raging for several centuries. Astronauts wear different spacesuits depending on the situation. Orange suits are used during launch, landing, and emergency situations inside spacecraft. White suits, on the other hand, are designed for spacewalks and are engineered to keep astronauts alive in the vacuum of space. The nearest large galaxy to the Milky Way is Andromeda. It lies about 2.5 million light-years away and can be seen with the naked eye on a clear night. In roughly 4 billion years, our galaxy will collide with Andromeda. The galaxies themselves, in their current forms, will likely be destroyed, but according to calculations, the solar system may survive. Place your bets. Venus takes 243 Earth days to complete 1 rotation on its axis, but only 225 Earth days to orbit the Sun. This means that a single day on Venus is longer than a year on that planet. No matter where we are on Earth, we always see the same side of the Moon. This happens because the Moon rotates on its axis at the same rate that it orbits Earth. Space is not a perfect vacuum. In addition to stars and planets, it is filled with cosmic dust, plasma, and cosmic rays, streams of elementary particles and atomic nuclei moving through space at extremely high energies. There is a little-known but important phenomenon called cold welding in space. If 2 pieces of the same metal touch in a vacuum, they can instantly bond together permanently. On Earth, this does not happen because air and moisture keep surfaces separated. Astronauts aboard the International Space Station do not walk. They float in microgravity. Because of this, the skin on their feet becomes very soft and begins to peel. So astronauts must remove their socks very carefully. Otherwise, skin particles would freely float around the station. Earthquakes on the Moon, or more precisely, moonquakes, are not science fiction. They occur almost as frequently as earthquakes on Earth and originate closer to the Moon's core. Scientists believe they are caused by the gravitational forces of Earth and the Sun. There is a hypothesis that Saturn's moon rear may have its own ring system consisting of 3 narrow bands. If confirmed, Rhea would become the first known moon with rings. Ordinary visible matter stars, planets, and galaxies accounts for only about 5% of the universe. Roughly 27% is dark matter, and about 68% is dark energy. Altogether, this means we know almost nothing about 95% of the cosmos. In the darkest regions of the universe, temperatures can drop to 270 degrees. Yet on the sunlit side of near-Earth orbit, temperatures can reach 120 degrees Celsius. This is why astronauts' spacesuits are white. The color reflects solar radiation efficiently. Astronauts can remain aboard the ISS for long periods because the upper layers of Earth's atmosphere partially protect them from solar radiation. At altitudes above 500 kilometers, radiation begins to have a severe harmful effect on the human body. And if the station were to rise too high, Earth's gravity would weaken enough for the ISS to drift out of orbit. That is why astronauts undergo intensive training in microgravity conditions before traveling to space. But this raises a logical question. Isn't there zero gravity in outer space? And if so, how do spacecraft travel to the Moon and other planets? In reality, when a spacecraft is far enough from a massive celestial body, such as during a journey between Earth and Mars, gravitational influence becomes extremely weak and is barely noticeable. However, no matter how far apart celestial bodies are, their gravitational interaction never becomes truly zero. Earth is falling toward the Sun in the same way the International Space Station is falling toward Earth. The difference is that due to Earth's high sideways velocity, this process has been going on for about 5 billion years. If planets and stars remain locked in their orbits for billions of years because of gravity, another question arises. Where do shooting stars come from? What we call shooting stars are actually small rocky objects drifting through space. At some point, their paths intersect with Earth's orbit. As these objects enter Earth's atmosphere, they compress the air in front of them at tremendous speed. This causes the air to heat up rapidly and glow. From the ground, we do not see the rock itself or the hot gas behind it. Instead, we see a bright streak of light that looks like a star falling toward the horizon. Most of these objects burn up completely before reaching the surface. Because they are only a few kilometers above us, they appear comparable in size to stars that are actually thousands of light years away. Scientifically, shooting stars are called meteors. If fragments of a meteor reach Earth's surface, they are known as meteorites. Especially bright meteors are called fireballs or bolides. Every day, hundreds of millions of meteors enter Earth's atmosphere. Their combined mass can reach several thousand tons, and about 100 tons of cosmic dust too small to be seen fall onto Earth daily. The vast majority of this material burns up without a trace. Approximately 700 million years ago, a mysterious event occurred that transformed Venus into the extreme planet we know today. Astronomers cannot directly observe its surface because it is hidden beneath thick clouds. But data from space probes reveal that Venus is covered with volcanoes, tall mountains, countless craters, and vast lava plains. The temperature on Venus's surface is so high that it can melt lead, and the atmospheric pressure is so immense that it would instantly crush any living organism. On top of that, the planet's atmosphere is filled with toxic clouds of sulfuric acid with an extremely pungent odor. Carbon dioxide, the main component of Venus's atmosphere, together with sulfuric acid, creates an exceptionally powerful greenhouse effect. As a result, the lower atmosphere and surface of Venus are the hottest in the entire solar system. However, one modern scientific hypothesis suggests that billions of years ago, Venus was a very different world. Scientists conducted detailed studies and reconstructed a computer model of ancient Venus. It showed that for a significant portion of its history, the planet may have had oceans of liquid water, moderate temperatures, and stable tectonic activity. In its early stages, Venus may have closely resembled Earth. According to researchers, this favorable period lasted for more than 3 billion years. During that time, the planet was likely covered by oceans ranging from 10 to 300 meters deep, with groundwater present in the soil. Temperatures remained between +20 and +50 degrees Celsius. A comfortable climate not very different from Earth's. And this is the key point. For nearly 3 billion years, until a catastrophic event around 700 million years ago, Venus may very well have been a habitable planet.